Hello there. So in this video, this is the second of 3 videos. I'm going to demonstrate some of the functions on this power shield. So in the last video, I showed using this button. In this video, I want to show using these two 10 kilo ohm resistors as a voltage divider that we can use to monitor the voltage of the battery. So I did have a data logging project where I was using a battery, collecting data, storing it to a micro SD card, but when the battery powered down, or when the battery sort of died, I kept losing all of my data because the file on the SD card was open when the battery died. And it happened several times. So something like this would have helped a lot, where I could detect when the battery is going low and then change the function of the Arduino and stop trying to collect and save data. So these two 10 kilo ohm resistors are connected, well, will be connected to the battery. And to do that, I need to connect this jumper here. So J1. So that's actually right here next to the two resistors. The resistors are in blue, and I'm going to connect them now to what will be the screw terminal, okay, where the battery would be connected. Now I have a couple of options of how to measure that. So there is a space here to connect a tiny 85. So that would be here, but actually I'm going to use one of the analog pins of the Arduino. So I need to make this connection here, which is these 3 blue pins here. I'm going to connect the center one, which is connected to the middle of these 2 resistors, okay? And I'm going to connect it to its left pin. So now that left pin is connected to these 2 pins here, okay? The center pin here on this top one is connected to pin A2. And if you remember from the last video, the A3 is connected to this battery. So I'm going to make the connection of the center pin for A2 to this pin here on the left, and that connects it now to these 2 resistors through here. So let's do that. And so then every time I check the voltage on this analog pin, I'm going to get what the voltage is between these two 10 kilo ohm resistors, right? And so because there's two 10 kilo ohm resistors and I'm measuring in between, I'm going to get half of whatever battery voltage is on here, right? So I need to do some math in the Arduino to calculate, to double it, to get this voltage, okay? Because I'm only measuring half, right? The Arduino operates on 5 volts, so it can only measure a maximum of 5 volts. So if I take about 9 volts and divide by 2, it's about 4.5. So that's within the ability of the Arduino to measure that. Okay, so that's what I'm going to do. Now for this video, I'm going to use this. And this just has a battery connector on one side. And this is a voltage regulator soldered to some male 90-degree pins. And so what this does is it allows me to change the output voltage on this side that I'm feeding to the Arduino. And I'm going to show you on here what voltage the Arduino is getting. And so then at, well, in this case, 7.5 volts or thereabouts, I want the behavior of the Arduino to change. So let me just show you this thing here. So I have the clips from my multimeter here. I'm going to connect it to the output side. So this is ground there, and this is positive. Okay, just going to move these out of the way. There's this on-off switch. It's switched off right now, but let's connect the battery to the input side. And turn my multimeter on DC current, so, or say DC voltage. So really there's no voltage because it's off. But you'll see there's a potentiometer here. So if I turn that all the way, then I turn this on. The LED came on, and it's close to about 9 volts for this. Okay, and then if I turn this, so you can see it here, if I turn this potentiometer, you'll see the voltage will change. And I find in the beginning it changes very slowly. There it's changing, it's dropping. And then it actually drops quickly. Okay, so there's about 7.5, right? And then it keeps going. Okay, so using this, I'm going to show that I can monitor the voltage that this is getting and then change the behavior. But normally I wouldn't use this, okay? I just plug the battery straight into the board here. Okay, so I do actually need to connect the output to here, but I'll do that off camera, okay? So let's go to the computer. Hello, so here we are at the computer, and again, if you want a copy of this, you can download it from the Instructables in the description of this video. But this is the sketch, right? The programming on the Arduino that's going to help detect the low battery. And much of this is going to be the same as the previous one. I've just added the battery monitoring on top of the previous one. So the first two variables are ones that I probably want to change most often. So the first variable is low bat level. And this is going to be the level at which the behavior of the Arduino is going to change, right? So if the voltage of my 9-volt battery goes to about 7.5 or lower, then I'm going to change the behavior of the Arduino. This variable is sensor interval, and it's at 1,000. So this I'm going to use to determine how often I'm going to measure the battery voltage level, right? Because I don't need to measure it constantly. Normally I have it at something like 600,000 milliseconds, which is about 10 minutes. But in this case, for the sake of this video, I just put it at 1,000. So it's going to check the battery voltage every second. I'm going to declare the power pin as pin 4. So this is about powering the Arduino. And if you want more information about that, please see the previous video. But pin 4 is the same as the last video. The push button off function is still there, so that's going to be A3 again. My dummy function is the same, except I'm going to use pin 12 this time. All right, so that was from the previous video too, so you can see that if you want to know more about that, please see the previous video. And then these two variables I need for the battery function. So I need a variable to store the current battery level so I can compare it to my low battery level. Okay, so that's what that is. And then I need to record what time I previously measured the battery voltage, so I know when to, I'm going to compare it to the sensory interval, so I know when to measure again, right? Because I'm not going to measure constantly. So there's check off button is the same, power down is the same as before. Here's the function check the battery. Here's one for low battery, which I'm going to call when the battery is too low. Let's go down to the setup though. Okay, so here's the setup. So same as the previous one, I'm going to declare my power pin as an output and then call it high so I can keep power going to the board. I'm going to declare my do something pin as an output. And then I'm going to call that do something function, which again is a double flashing of that LED. And then I give myself a second delay just to get my finger off the button. And then declare my off button pin as an input pull up. Okay, and again, that's important to declare it as a pull up. Here down in the loop, so here I'm going to see if it's time to measure the battery function. So that's what this if statement is for. So I'm going to compare millis, which is an Arduino function that returns how many milliseconds since the Arduino was last reset. And I'm going to compare it to my previous time, the last time I checked the battery level. And so if the difference between those is greater than my sensory interval, then I'm going to call this section of code in here. Okay. If it's been too soon, I'm just going to skip these two lines. Okay. So if it is time, the first thing it's going to do is going to update the previous time measurement to whatever time it is right now. And then it's going to call this check battery function or check battery. Okay. So that function is here. Okay. And so this is where we check the battery voltage. So I need a pin to do that. So I'm going to use pin A2 and I declare it as an input. And then I'm going to read the voltage on that pin. Okay. So battery monitor. So if you know anything about analog read, the result you get back is between 0 and 1023, where 0 is 0 volts and 1023 is the maximum, which for the Arduino is going to be 5 volts. Okay, so to convert this to an actual voltage level, I'm going to take that number, whatever it is, and multiply it by 5, or 5 volts really, and then divide by 1023. Right, so that should give me an answer between 0 and 5 volts. And I'm going to store that as my battery level in this variable. Okay, but if you remember, what I'm actually reading is the voltage divider. So I've really split the voltage in two. So this next line, I'm going to take my result, battery level, and I'm going to multiply it by 2 and then just resave it as itself. So now I should have the voltage of the actual battery. Okay, and then in this line, I'm going to compare that voltage to my low voltage level. And so if my battery voltage is lower than my 7.5 volts, then I'm going to call this function. And so this is where I changed the operation, so the behavior of my Arduino. Okay, so if this is your project, you could just change this to whatever you want. But here's my low battery function. So I'm going to declare a pin, my low battery pin is number 13, make it an output. And then in this for loop, I basically flash that LED on pin 13 10 times, right? Call it high, delay, and call it low, delay. And so it'll do that, run that 10 times, and then it'll go back to the loop. Okay, and it goes back to here. And then since this is over, it goes back to the loop. Okay, so that's here, it's down in the loop. So once this is done, it's going to check to see if the off button is pressed, right? And so it can turn off if it needs to. If not, it's going to do the do something dummy function, okay, which again is flashing the white LED in this case twice. Okay, so that's it. Again, another small program, so only 7% of the storage space, 0% of the dynamic memory, because really this is just meant to add on to a larger project. Okay, so this just adds on battery voltage monitoring, so we can change the function of the Arduino. So let's go back to the shield. Let's see, so let's power up. So now there's about 9 volts, and that's going into the shield. Okay, but the power's not going because I haven't pressed this button. Okay, so let's try pressing the button. So there, it's working. Okay, and the voltage is about 8.6 volts. So that's higher than my 7.5 volts. So nothing's happening with my red LED because the battery is not considered low. Okay, so now let's change the voltage. And it might not be exactly 7.5 volts, right? It's like, you know, the accuracy of the meter and the accuracy of the two 10 kOhm resistors. But hopefully you can see here as I lower this. There it's dropping. But at about 7.5 volts, the red LED should occasionally start flashing for the 10 times. See, so we're at 8. Oh, here it dropped quickly. But it's still, we're still above 8.5 volts, so it hasn't started. But there, now there's my low battery. It's going to flash 10 times, and it's going back to my do something function. Okay. And the way I set it up is that if for some reason the battery voltage would go back up, then this LED would stop its flashing. And there we have it. Okay, and if I drop it again, .7 volts, 7.55, so that's enough to activate my low battery function. Okay, so it's about 7.5 volts, like I said. And then again, this push button is still being used as my off button. It should be. There we go. Okay, so that's how you add low battery monitoring on your Arduino. Okay, using the double resistors. Okay, and my next video, I'm going to show using this 555 timer as an external Watchdog timer.